Subtyping is a relation between two types, and it captures the idea that one type describes a smaller set of values than the other type. For example, in Mo we have an int type, and if we were to add another type for positive integers, posint, then posint would be a subtype of int, because posint has the numbers 0, 1, 2, 3, and so on, whereas int has all those numbers and then also the negative numbers. Let's go into detail about subtyping, and we'll use records as a motivating example. As a reminder, here's our syntax for Mo with records. We use curly braces to create a record, and between the curly braces we have symbols mapped to expressions. We can get a value out of a record by using this dot syntax, and then we have the with syntax to do a functional update of the record. The with expression returns a new record, where the symbol name here is mapped to a new expression. And finally, we have the types. In addition to int, boolean, and function types, we now have a type for records that has a symbol for every name in the record and a type to go along with each symbol. As a first example, here's a record with fields x and y, and the type for this record says that x has type int, and the field y also has type int. This type matches the record because the expressions up above will both reduce to integers if we interpret them. This example has a nested record. So on the outside, we have a record with the field p, and p is bound to a record expression. And this record on the inside has x and y fields. The type for this record says that p has type record, in particular, a record where x has type int and y has type int. If you do a get on the record that we saw before, then first, the type of this expression is an int, and second, we know that this field access is guaranteed to succeed at runtime. We know that getting y won't result in an unbound field because the record's type says that y is one of the valid fields inside that record. And if we have our nested record from before, then we can do a chain of field accesses, first getting the p field, then getting the x field. And both of those accesses are guaranteed to succeed based on the record type that we have. A set expression will also have a record type, and in this case, the type for our set result will be the same as the type for this record where x is bound to 3 and y is bound to 0. Here's a slightly bigger example where we take our xy record and then we add the two fields together, so r.x plus r.y. And based on the types, we know that both those accesses are sure to succeed. Now, suppose we have a function here. So there's no record values in this program, but we do know, based on the type of the function argument, that this r.x inside the function body is guaranteed to succeed, as long as our function is called with a well-typed input. And overall, the type for this function says it takes in the record with the field x bound to int and returns an int. This function takes in a record r and does a set on the record's x field. Its type says that it takes in an x int record and then returns an x int record. Here's one more example. F is the function that we just saw, which does a record set. We apply f to the record where x is bound to the expression 1 plus 1. And since the type at the call matches the type inside the function, we know that the set expression is guaranteed to succeed and give us a new record with the field x and the type int. Let's move on now to typing rules. Inside of some type environment, we can conclude that a record here has type tau if we can show on the top that every expression inside the record, from en up to e1, those each have types tau1 to tau n. And then once we do that, we build up the overall type tau by matching up each of the field names with those types. The typing rule for a record get says that e.xi has type tau I if e has a record type going from x1 to xn, and xi is one of those names. If it is, then the overall type is the matching type, tau I. And now for a record set, e1 with xi mapped to e2 has a record type as long as e1 has the same record type and e2 has a type tau I that matches the xi on the inside of the record.